This is actually a review, okay? Because I need you to review to remember where we stopped off the last time we talked about moles. Was we interpreted equations like this in terms of moles. Oops, I don't want all those. Right? Okay. We interpreted. How do we interpret this in terms of moles? Well, that was the easiest one to do. Okay. I got Al2O3. How many moles of Al2O3? 2. So that would be 2 moles of Al2O3 makes 4 moles of Al and 3 moles of O2. Because remember, this was really just scaled up from individual particles. We just did it a whole bunch of times. It was really 2 particles, 2 formula units of Al2O3, 4 atoms of aluminum, and 3 molecules of O2. But that's if you do it particle at a time, but we did lots of particles at a time. Okay? And we actually proved this part that because it was true in moles, the law of conservation of mass worked. Right? That's why we went through this. Okay? So the coefficients tell us how many moles. Okay? And coefficients are the numbers written where? Before, yeah. In 2xy cubed, the 2 is the coefficient. Okay, so let's see what that lets us do. Hey, if I did 4 moles of Al2O3, how much oxygen would I make? Well, I did 4 moles here. That means I did this thing twice, right? So you'd expect 6 moles of O2, right? That seem reasonable? Okay, that's the explanation. What does the math look like? How many moles of O2 are produced when 3.34 moles of Al2O3 decompose? It's that same reaction. Now, the last one I could do in my head, okay? But we need to be able to show that our units work out. So the central idea of the next unit is that we can read these equations in moles. And that if I can get to moles of one chemical, I can change which chemical I'm talking about. Because we haven't done that yet. Okay? And I'm asking you about oxygen, and I'm telling you about aluminum oxide. Right? I'm telling you about aluminum oxide and acid. So I'm telling you about one chemical and asking you about another. And you can only change from one chemical to another if you've got a balanced equation and read it in moles. Because I'm going to be able to say 3.34 moles of Al2O3. And then I'm going to ask myself some familiar questions. What unit do I want to get rid of? I want to get rid of moles of Al2O3. Okay? So moles of Al2O3 has got to go. To get rid of it, it's already up top. It needs to go on the bottom. Okay? And what do I want to turn those moles of Al2O3 into? Moles of O2. So my conversion factors is going to have moles of Al2O3 on the bottom and moles of oxygen on top, and I get the numbers out of the equation. So it says Al2O3 has a 2, so that says 2 moles of Al2O3 will make 3 moles of O2. But I got the 2 from there and the 3 from there. I took the coefficients right out of the equation. This is the useful part of balancing equations. All we did up to this point was say, oh, they're equal amounts. well, darn, it's always equal amounts. I don't have to do all that work to figure out it's going to be equal amounts. It's always equal amounts. But the fact that I can do it in moles is going to let me figure out how much I make. Because I'm telling you how much aluminum oxide you started with, and you're going to answer with how many oxygens I made. Okay, so you remember numbers on top you multiply, numbers on the bottom you divide. 3.34 times 3 divided by 2. My calculator screen fills up with numbers. How many do I get to write down? Well, 3.34 has 3 sig figs. What about this 2 and 3 that I used? Is it ever going to be 2.01? It's got to be an integer, right? It's got to be a counted number. So these are the ones next to moles are unlimited sig figs. It's exactly 2 and exactly 3. 2.0000 forever, right? So it's 3 unlimited and unlimited, so my answer should have 3. That works out to be 5.01 moles of O2. So that's one of the conversion factors I could have made out of this balanced equation. Actually, I can make 6 because I can go the opposite of this one, right? And then I can go from moles of Al2O3 to moles of Al, which is actually probably what I'd want to know. I want to know if I'm tearing apart aluminum ore, I'm really going to want to know how much aluminum I'm making. That make sense? Okay, so that would be 4 moles of Al over 2 moles of Al2O3, or that flipped over. The Al2O3 on top and the Al on the bottom. And then I can actually do these two. Every time I make 4 moles of Al, I make 3 moles of O2. So I can make a conversion factor with Al on top and O2 on the bottom, and vice versa. So you can make conversion factors out of anything in the equation because they have that mole relationship. Okay? So the book is going to ask you practice making some. All you got to do is make all the possible ones by copying the numbers out of the coefficients. Not a big deal, right? But we usually don't write all of them. We just pick the one we need. So this is the formula for what happens when you use cutting torches. Ever seen somebody working on steel where they light the torches and use that to cut? Well, C2H2 is acetylene. Acetylene is one of the tanks. Then they have a second tank, oxygen, so that they can have fuel and oxygen. Because what kind of reaction is this? It's a combustion. Okay. So if 3.84 moles of C2H2 are burned, how many moles of O2 are needed? Well, it should be pretty easy. I start off with writing down what they told me I want to change. What do I want to change? I want to change the moles of C2H2. So I write the 3.84 moles of C2H2. So what unit do I want to get rid of? Moles of C2H2. Where's it got to go? On the bottom, because that has one on top, one on the bottom, then they cancel out. Okay? I can turn moles of C2H2 into moles of anything else in this equation. Which one should I choose? Well, since it asks about O2, I should probably choose O2. And then I've got moles of O2. Now I just need to know what numbers go in front. The number in front of O2 is a 5. So I'm going to put a 5 in front of O2. Number in front of C2H2 is a 2. I'm going to put 2 there. Just copy them out of the equation. That's the benefit of being able to read it in moles. So then I've got the unit I want. I've got moles of O2. So 3.84 times 5 divided by 2 equals, my calculator gives me 9.6, and I write that down, and Mr. Green marks it wrong for 2 reasons. Reason number 1, there's no unit, mole O2. Reason number 2, how many sig figs in 3.84? 3. How many in the 5? Unlimited is a counted number. How many in the 2? Unlimited. So I got 3, unlimited, and unlimited, so my answer should have 3 sig figs. But my calculator only said 9.6. What can I do to make it 3 sig figs at 9.6? Add a 0. That 0 counts there. That's the place the 0 at the end counts after the decimal point. We haven't done sig figs for a few months, so I'm going to review those sig figs rules while we're doing this. Okay? Extra super hard? Okay? That time I turned it into the O2, because if you had 2 tanks, you would need to know you want to have enough so that you weren't going to run out of both of them. You would want to run out of one before the other. Same equation, so you don't have to rewrite the equation. How many moles of C2H2 are needed to produce 8.95 moles of H2O? Well, I start off, it doesn't want to let me write in that one spot on my screen. So I start off with the 8.95 moles of H2O. What unit do I want to get rid of? Moles of H2O. What can I turn moles of H2O into? Well, anything in the equation. So since they asked about C2H2, probably which one I want to pick. Then I'm going to copy the numbers. The number in front of C2H2 is a 2. The number in front of H2O is a 2. Hopefully you don't need a calculator. 8.95 times 2 divided by 2 is going to be 8.95 with 3 sig figs, moles of, well, it didn't change the answer. Yeah, it did. Because a mole of water does not look like a mole of C2H2. A mole of water could help keep you alive. A mole of C2H2 could help you explode. Because it's exposed, it's a flammable gas. I mean, they're using it for cutting torches. Okay. Extra super difficult? Okay. So, come up with an answer on this one. Let's see if we get the same answer. So you got 4.94 moles of CO2. So I can tell you about a reactant and ask you about a product. I can tell you about a reactant and ask you about the other reactant. Okay. Those last two examples. Or I can tell you about one product, different equation. I can tell you about a reactant and ask you about a product. How many moles of water are produced when 5 moles of oxygen are used? Well, get rid of moles of O2. Change it to moles of H2O. 1 mole of O2 for 2 moles of H2O. So my answer is 10.0 moles of H2O. 2 times 5 is 10. 10 with 3 sig figs is 10.0. Yeah, that's right. It would be. Because that 0 is after the decimal point. That means the other one's in the middle. So it's between. Hey. So this is what I'm expecting your homework to look like. Okay? We want to see the conversion factors. Because life isn't this straightforward. What do you mean it's not this straightforward? I said 5 moles of O2. How am I going to know if I got 5 moles of O2? Am I going to count? Am I going to weigh? Could I weigh oxygen? Try to picture yourself weighing oxygen. Can you see a problem with that? Oh, even worse, picture yourself trying to weigh helium. You put it on the balance and it leaves. Does that mean it has negative mass? No, it doesn't have negative mass. It just weighs less than the same amount of air would weigh. So that air takes its place. That air falls by gravity, and the other one moves out of its way, because the heavier piece takes its place. Okay. So we got some problems, because this is true, but we can't measure moles. What can we do? What can we measure that will get us moles? We convert grams to moles. Hey, the last time we did, that's what we did. We figured out how many grams that stuff would weigh. So grams I could weigh. And then I could convert that into moles. And I'm going to do that off the periodic table. Then I can use the conversion factor we just learned to change what chemical it was. Because if you look at your last conversion factor, you didn't change the mole part. You changed the H2O to O2 part. Remember last time, all this time, people asked me, do we have to write the chemical after mole? And I said, yes, eventually that's the part that we're going to change. Now is eventually. Okay. And we're going to get those numbers from the balanced equation. And then we'll be able to turn those moles back into grams. Okay? So that's what we'll be doing on Monday. So over the weekend, I need to be practicing going from moles to moles. It should be pretty straightforward. Actually, the first two questions have the answer right next to them. So I'll be looking at the work. So have a great weekend. Restore the balance. I will see you on Monday.